So the first question we're going to look at says how many distinct numerical values can be represented with 8 binary digits. So first we're going to think of something that's a little simpler. So we're going to talk about how many numbers can be represented by 2 decimal digits. Okay, so 2 decimal digits, the biggest number that I can represent is 99, right? But we also can represent 0. So we can represent 99 numbers plus 0. So 99 plus 1 means we can represent a total of 100 different numbers with 2 digits. So thinking about this more, what number is equal to 100? That's 2 to the 10th. I'm sorry, not 2 to the 10th, 10 to the second, right? So that gives me 100 numbers. And basically, if you take the number of digits and raise whatever number system you're in, decimals base 10 to that power, so 10 to the second, that will tell you how many. So looking at ours, how many distinct numerical values can be represented with 8 binary digits? So I actually have a picture of that here. There are 8 digits here because we're starting out with 2 to the 0 up to 2 to the 7th. Remember, this is called a byte. Just for some vocabulary, right? 8 bits is called a byte. We saw that in the previous video. So if I think about it, if I'm talking about these 8 digits, this is the 128th place and the 8th digit, but I can keep adding on all these numbers, which would get me up to just before 2 to the 8th, which is just before 2 to the 8th, which is 256, is 255. Plus we have 0, right? So 1 through 255, 0 is one more number. So we have 256 unique numbers that can be represented with those 8 binary digits. And we could have just done 2 to the 8th for that, just like we could have just done 10 to the second to find out how many decimal numbers can be represented with 2 digits. So the next question is going to be slightly different. Let me just scroll down to that. What is the largest value that can be represented by 6 binary digits? So we know to figure out the total number of numbers that can be represented, we can just do 2 to the 6th, which is 64. But this question is slightly different. It says, what is the largest value? Okay, so the largest value, we can't do the number 64. That bumps us over to the next digit. So we're going to do -1. The largest number I can represent is 63. Just like on the previous question, the largest number I could have represented with 8 binary digits was 255. Okay, so slightly different questions. How many distinct values? You can do 2 to that power. The largest value, 2 to that power -1. So our last question has to do with memory. And this says a computer database uses a binary sequence of 9 bits to represent unique user IDs. To increase the number of unique IDs that the database is able to represent, the database administrator increases the number of bits in a user ID to 15 bits. How many times more unique user IDs can be represented with the new system? So we're thinking of binary numbers here. Basically with 9 bits, I could represent 2 to the 9th binary numbers, right? Unique numbers like the previous question. When I go up to 15 bits, that's 2 to the 15th. So I don't necessarily even need to know what 2 to the 15th is on this problem. We're just saying how many times more. So when I say how many times bigger a number is than another number, like how many times bigger is 20 than 5, I would just divide those two numbers, right? So 20 is 5 times bigger or 4 times bigger than 5. So here, I just need to divide my new number of numbers divided by my old number of numbers. When we have the same base, we keep the base and subtract the exponents. So by adding on those 6 extra bits, I get 2 to the 6th times more new passwords or IDs in this case, which equals 64. So basically each time I add an extra bit, I get double the amount of whatever I'm talking about. Okay, so we've doubled 6 times, which is 2 to the 6th, which gives me 64.